Hello, today we're going to talk about keywords that will help us know how to set up an equation from some words or phrases or an application problem. So initially here, we're just going to be looking at some keywords. And so we'll start with some of those that key us into that something is an addition problem. And the first word that I'm going to put on the list is sum. S-U-M. And the sum is the answer to an addition problem. So if you see sum, the sum of this and that means you're going to add them together. And just like what I just said, you might have just add, right? As simple as that. Total increased by, or just increased, more than, and then I'm going to also add to this combine. Like when we think about combining like terms, we're adding them together, but sometimes we have to pay close attention to their signs, but combine. I want to let you know that for addition, you could change the order. So if I said a number, the sum of a number and 7, so like x plus 7, or I could say 7 plus x, right? That means the same thing. So there is a property in math called commutative property, and it just says that for addition and multiplication, the order is not important. We get the same answer, but that's not true for subtraction and division. So we're going to have to be a little more careful with our setups. We'll have less options of how to write things for subtraction and division. All right, moving on to subtraction. The answer to a subtraction problem is called the difference. So if you see difference, you know it's going to be subtraction. We might also just see subtract, which is a pretty obvious one, or minus. Just going to add it to this line. Or perhaps you might see takeaway or giveaway. And then similar to on the left for add, we had increased. We might also have decreased. Or we could hear the word decline. Decreased is much more common, but that prefix DE tells me something is going down. And subtracted from and less than. Not is less than, just less than. And these two we're going to talk about again as we go down the page, because there's going to be something special about how they are arranged. If I said some number, so some number, we'll just call it x, take away 5, the difference between 5 and 3, 5 minus 3. So for these first 4, we keep them in the same order. But for these last 2, we'll handle those in a minute because it does make a difference. If I said the difference in between 5 and 3 or 3 and 5, the sign would be different. So like having $5 and spending $3, you still have $2 left. But if you only have 3 and you try to spend 5, you don't have $2 left. You owe $2. So that's different. All right, so let's go on down. We'll have more examples for all of these that we'll work through together. Okay, so for multiplication, the first one I'm going to give you is again the answer to a multiplication problem, and that is called the product. We might also just see multiply. I don't know what is happening here with my writing. Let's erase and try again. Oh, sorry about that. Or times, right? Times, 3 times 4. We know we're talking about multiplication. You might also see the word per. And then we're going to have some words that mean multiply by a specific number, like twice or double mean to multiply by 2 specifically. And then triple means multiply by 3. Multiplication, we can write things in either order. As we go through some examples, I'll show you more than one way that those things can be written. And then division, which sometimes we're going to see written as a fraction. So division, the answer to division is called the quotient. The quotient, Q-U-O-T-I-E-N-T, the quotient. And of course we can say, and we'll often hear divided by. Quotient, division, we have to be careful of the order. 20 divided by 2 is not the same as 2 divided by 20. So not the same. So order matters. We might see split or shared. And typically these will talk about equally, split equally or shared equally, or that will be the assumption. For instance, if we go out to lunch together and we split the bill, that typically means we're just going to share it equally no matter what we each had. And then we also might see half or half of, which can mean multiply by the fraction, but it also is the same as dividing by 2, which is oftentimes an easier way to handle that. Okay. So that gets us through our 4 main operations. And then now we have some phrases that let us know sometimes we have a little more complicated situation that we will be using parentheses. And so one of those, they're similar to each other, but they basically have to do with when we have times or multiply times the sum or times the difference. And keep in mind that times could also, we could use the word twice or double or triple, because those mean times 2 or times 3. So that would still, if those words were followed by the sum or the difference, they would still be a time we want parentheses. Like the other things, we'll see an example here in a few. And then we have some turnaround phrases that we actually listed above in our subtraction examples. And the most common of those are less than, and subtracted from. So if you told me that you have $20 and I said, oh, I have 5 less than that. I have five less than you. Well, that would mean you would take the 5 away from your 20, not take the 20 away from my 5. I would write the 20 first minus 5. So if I said something like 3 less than a number, well, first off, a number, we're just going to give a variable. So like x for a number, but 3 less than a number means I'm taking 3 away from something. So that's why the 3 is written first in words, but with less than, the x or whatever follows the then is what is written first, and then we're taking 3 away from it. Once again, we'll see some more examples. But just be alert. Sorry, this is supposed to be subtracted from. So for instance, 2 subtracted from 10 means I'm taking 2 away from 10. Not 2 minus 10, but 10 minus 2. We start with the thing that follows the from. Like, where are you from? That's where you start. Oh, sorry about that. Okay, I have to zoom out just a little so we can get the full width here. Okay, so now we're going to be, these are some examples, and the first ones are just expressions. So expressions, remember, there will not be an equal sign. And then on the back side of the page, we will get to some that are equations. But at first, just expressions. And we're not trying to solve or simplify. We're just trying to translate it into algebra. So each time when you see some of these keywords, you should look, if you don't remember, look at the top of your list to see which category it's in, like which operation. And when it says a number, I don't want you to choose a number. I want you to like represent that, for instance, with like a variable. So I'm going to use n for a number, but you could use x or whatever letter you choose. So the product tells me which operation? Yeah, multiply. The product of a number and 3. So a number times 3. Or we could say 3 times a number. Or we could say 3 parentheses a number. The simplest and most common way, if it's a variable and a number and they're being multiplied, would just be to write the number as the coefficient of the variable. That's how we're most likely to see it. The other ways I wrote it are all fine. I would not use an X to represent the multiply because now we're using X as a variable. So I would get away from that. Okay, so number 2, the difference, subtraction, right? Between a number, so a number and 10. Not sure why my 10 is not. There we go. That's it. In that order. We don't have like 5 different ways to write this. Minus is our only subtraction symbol, and it does have to be in that order. So the only difference, the other ways you could write this is with different variables. The quotient of a number and -5. Quotient, division, right? So we could write n divided by -5. Or more commonly, when we're writing algebra, we usually write it in a fraction to indicate division. Again, both ways are okay, but this is what you would more often see in an actual algebra equation. Okay, number 4. 4, subtract it from a number. Okay, so I see subtraction, so I know I'm going to need a minus somewhere, right? I got to subtract something. But what am I actually taking away? I'm taking away the 4 from the number. Remember, subtract it from is on our turnaround phrase list. So you start it where you came from, right? You start with the n, a number, take away the 4, subtract the 4 from the number. If I just said 4, subtract a number, it would be 4 minus n. But subtract it from means we got to start with what's at the end. The sum, well, that tells me plus twice a number. So now I need to keep reading to see what am I adding together. I'm adding twice a number. Well, twice a number, we said means 2 times some number. And what else is being added to that? 7. So it might be a little confusing. You might think, wait, plus, but now we're multiplying, but we are adding something that has been multiplied by 2 to the 7. Someone might write 7 plus 2n. That would be the same, but I think the order that it's written in, this probably makes more sense. The product, which operation? Multiplication, right? The product of a number and 10. So we said when we have a variable and a number and we want to multiply them, just write them next to each other. It becomes the coefficient. And then increased plus 1, increased by 1. Someone could write the 1 plus 10n. That's okay too, but I think writing it in the order you see it, unless it's a turnaround phrase, is usually the safest way. Okay, let's see here. Head on to the back of the page. So 4 less than, okay, now less than turnaround phrase. So this order is going to get switched. So 4 less than means I'm taking 4 away from something. Notice I left myself some space before the -4. What am I taking it away from? A number. squared. Squared means second power, so it has an exponent. Number 8, twice a number. Twice, remember, means 2 times, so 2 times n, twice a number, divided by 5. Now, at this point, we have had only expressions, but now we see over here at the side that it says equations. So now that it says equations, there will be an equal sign, and typically where we're going to put that equal sign, we're going to see the word is. There are some other words, but that's by far the most common. So in number 9, the sum, so I'm adding something together because I saw the word sum. What am I adding together? Twice a number, so 2 times a number, and 10, and then is 36. Right, number 10 is our an example. I see times the difference. So this is going to be a time when we need to use parentheses. So we want to multiply 3 times something, but it's not just one number or one, it's just the difference of something. So 3, and then inside here, we're going to be writing something that's the difference. So we know it will have a subtract sign, a minus in the middle, a number, and 7. So that a number and 7 are the 2 things that we're subtracting in that order. And then is, so equal 18. Number 11, 4 times a number, 4 times a number. Again, I've used n, but you could use x, or I could use c, since it's my initial if I want. 4 times a number divided by 8 is 3. Now, we could solve these, but they might have some messy answers. We don't need to solve them. We're just practicing on translating them into algebra for now. Number 12. Times, I see times the sum. Okay, 5, so 5 wants to multiply with something, but it's not just one thing, it's times the sum. So we need to use parentheses. N, so a number, and 6. That, close up the parenthesis, and then is, there's my equal sign, 48. All right, nice job. At any time, if you want to try the next thing and then start the video could have told you that sooner, right? You might have already figured that out, but you could pause me and try something and then come back. I'm gonna try to make this just a little bit bigger for now. Okay. So number 3, 1/2 of a number. So we said 1/2. We could say a number divide by 2 would give us 1/2. Is, so we already got our equal way up here. 8 less than, turn around. So I'm going to leave a little space and I'm going to take 8 away from something. What am I taking it away from? The number itself. So n minus 8. The ones in this section are a little more complicated, so try not to be overwhelmed. It's okay. The product tells us which operation? Multiply. So a number and 3. So 3n is the same, so equal, as the sum. So I'm adding something over here together, that number, so this means use the same variable, and 6. So plus 6. Okay, I might have said number 3 and that's actually number 13. So hopefully that didn't lose anybody a couple problems ago. Number 15, 15 decreased by, so we're going to subtract something from 15. What are we subtracting from 15? The quotient. So we have to, a division, we typically write that as a fraction. So quotient of what? A number, so top to bottom, and 3, and then is 20. So decrease by means we're going to subtract. What are we subtracting? The quotient, so we're subtracting that fraction, and then it is equal to 20. Number 16, for less. Okay, for less than turnaround. So the 4 is going to move out here. So I'm taking 4 away from, what am I taking it away from? The product of a number and 7. So that means 7 times the number. So that's all up till the is. So that equals 8 more than that number. So 8 plus n. Now, some things could I write a little bit differently? Well, things with addition, I could switch the n and the 8, but much of this I couldn't write in a different way because of the subtraction being involved or where the is placed. Has to be where the equal is. All right, this next part, we're going to talk a bit about inequalities, and I know that you have solved inequalities previously and graphed them. So I want to point out that we see less than here, and I want to make sure that we understand the difference between when it's an inequality compared to when it's a turnaround phrase. What you're going to see is that it has is with it, because when I read this, 5, when I read that, I don't just say 5 less than 8. I say 5 is less than 8. Or if it was x is less than 8. There's an is in there. So I kind of wish the paper had is in front of all these. So if you see this and you think, well, I thought less than was a turnaround, but this is less than. So it's a cue that it's, instead of being a turnaround phrase, it's an inequality. So is less than, we're using this symbol, is less than or equal to, we give it the equal line, one of the bars, greater than and greater than or equal to. So again, when we see a number, we can use n, we can use x. I might just change it up and use x now. If you still want to use n, it's perfectly fine. A number is less than -10. Is less than. So I say x is less than -10. A number is less than, so a number again is less than or equal, give it the line, to 8. a number is greater than or equal to -4. So those three are pretty straightforward. When we get the rest of these, we have to do a little more thinking. So a number is at most 45. So when it says at most, that means the 45 is as high as it can be. So that's as high as it can be. So it could be less than, or it has to be less than, or it could even be equal to 45. So at most 45 would be like 30, 35, 40, 41, 42, 45, right? At most 45 means 45 is the highest. So that's why it's open to the 45. That is the highest. A speed limit, we should stay less than that, right? So we would want to be less than 55. Is it okay to go 55? That's still the limit. You can meet the limit. So less than or equal. 22 is like an opposite of 20. A number is at least 16. So if it's at least 16, it could be more. 16 is the lowest it can be. So saying at least means greater than or equal to. So it could be 16, 17, 18, 25, 2000. It could be a lot. Now we have some that have, pardon me, no. We have a no in here. No less than 10. So if it's no less than 10, that means it could be 10 or it could be bigger than 10. So greater than or equal to 10 if it says no less than 10. No more than 26. So would have to be less or equal to 26. A maximum number, maximum means the highest. For instance, in an elevator, there might be a maximum weight or it would not be safe. So a maximum of 25, it's kind of like a limit. So we would want it to be less than or equal to 25. 25 is the highest, so the symbol is open to the 25. And minimum means the opposite. It means the lowest possible. So it would actually be numbers that are greater than or equal to 5. All right, wonderful. I hope this is helpful and gives you a good start.